So this, so what we will be studying in case of in this unit is that we actually have a number of waveform generators. We can generate sinusoidal waveforms, square, triangular, saw-shaped. We can have DC waveforms. We already know how waveform generators work. We are not dealing with the generation part. We are dealing with the analysis, the measurement part. Uh, so signal analyzers, what they'll be used for, they'll be used, we'll be using signal analyzers for analysis of those waveforms, those generated waveforms. So say for example, we have a sinusoidal waveform. It has a certain harmonic distortion associated with it. So we want to measure this harmonic distortion. We want to measure the THD of the sinusoidal waveform. We want to measure we want to do the power analysis. We want to see the distortion in these waveforms. We want to see the stability of the output of these waveforms. So for all those characteristics for analysis, for studying the distortion in these signals, for studying the noise, amount of noise in these signals, for studying the magnitude and the frequency response of these signals, for understanding the stability of those waveforms, we need signal analyzers. So there are a number of analysis that we'll be covering under this unit. So we'll be looking at the harmonic analysis, we'll be looking at the waveform analysis, we'll be looking at the spectrum analysis for measurement of THD extra. So this unit focuses on the analysis of any generated waveform. This analysis can be measurement of harmonic distortion. This analysis can be measurement of stability or steady state characteristics of the system. This can be measurement of noise, disturbances, extra. Right. So analysis of that will involve both the transient response analysis, the steady state response analysis, be it stability, be it understanding the distortions, the noise, the harmonics in in any waveform. Particularly, we are dealing with sinusoidal waveforms. We are dealing with AC waveforms. So we need to understand the we need to do the analysis of uh, these signals. So first up in this unit, we'll be understanding the wave analyzers. So what is a wave analyzer? It's basically a device that can actually help us measure the amplitude of a particular frequency component of any waveform. Fine. So I hope you are already covering this portion in the power electronics, the THD portion. You know that in any sinusoidal waveform, there will be other associated distortions that will actually be waveforms of that will be actually multiples of the frequency of the fundamental component. Okay? So your AC waveform is not purely sinusoidal that you are generating. It will have other frequency components as well, and these frequency components will actually be the multiples of the fundamental frequency components. So you'll have a sinusoidal waveform associated that will be a multiple of say for example your fundamental frequency is 50 hertz, तो आपके पास एक और sinusoidal waveform होगी जो 100 hertz की होगी, उसका magnitude but कम होगा. Fine. So you'll have another sinusoidal waveform that will have a lesser amplitude, but that will be associated with the fundamental frequency waveform that will actually cause the distortion of your sinusoidal waveform. ऐसे आपके पास 3fs होगा, that means 150 hertz पे, 200 hertz पे, 400 hertz पे, 450 hertz. So you'll have all these frequency components added up to your fundamental frequency component that will actually cause the distortion of that frequency of your fundamental AC waveform, fundamental frequency AC waveform. So what wave analyzers help us? It helps us calculate the amplitude of a particular frequency component. So you will do this, you will do the Fourier analysis there. You will see that every waveform is made up of the fundamental component 2fs, 3fs, 4fs, 5fs, and so on. Now you want to measure an amplitude of a particular fundamental, particular frequency component. Say for example, there is a component 5fs. There is a component जिसकी frequency 5 times 50 hertz है. That's 250 hertz. We want to measure the amplitude of this particular waveform. We want to see actually how much distortion it's causing. So for understanding how much distortion it's causing, we want to understand its amplitude. Wave analyzers can help us calculate the amplitude of a particular frequency component. Fine. So this uh, device is used for measurement of the amplitude of a particular frequency component. And how we do this is by actually tuning the circuit. We'll be actually tuning this circuit to that particular frequency. The circuit will be tuned to the particular frequency, whereas all other frequency components at that time will be rejected. Using filter circuit, we can reject a particular frequency, and we will be using a band pass filter so that only a particular frequency is selected, whereas all the filter components, lower frequency components, or the higher frequency components will be rejected. So only one frequency component will be available to us, or a range of frequency component will be available to us, जिसमें एक particular frequency component खाली significant होगी जिसका हमें amplitude निकालना है. Fine. So this is what a wave analyzer does. Uh, so इसका जो basic block diagram है, how it looks like is. Okay, so I was talking about the block diagram. So this will be the basic block diagram of any wave analyzer. So first step in wave analysis is attenuation of the frequency of this particular signal, then passing it through an input amplifier, passing it through a filter that will select the particular frequency component. The magnitude of these, if we are talking about, say for example, audio signals, the magnitude of the signal itself will be very low. So we need an input amplifier first. Then once we filter it, we are getting a particular frequency component. Say for example 100 fs, fine. तो उसका जो एम्पलीट्यूड होगा वो और भी ज़्यादा कम होगा. So we need also an output amplifier. Whereas बाकी सारी frequency components will be rejected and the noise extra will be attenuated at the front only. So then once we have obtain that particular frequency component. We want to measure its magnitude, and that will be fed to the metering devices. So, uh, so the signal that needs to be analyzed here is actually first and applied to the input attenuator. Fine. So the meter will actually metering device will actually only be calibrated to measure the magnitude of this particular frequency component. Fine. Once we attenuate this, attenuation की जो characteristics है that I'll show just right now. Once we attenuate this, we actually removing noise extra in the system. We then pass it through an input amplifier. As I'm saying to you, we are measuring, say, for example, audio signal. Audio signal का magnitude already कम होगा, so we need to amplify the signal in itself. So we'll be amplifying the signal using the input amplifier. This then we can actually pass it to a filter. So this filter will actually be a band pass filter. ठीक है, so बैंड पास फिल्टर का मतलब है कि एक पर्टिकुलर फ्रीक्वेंसी कंपोनेंट आप सेलेक्ट कर रहे हो while rejecting all other frequency components. So we'll be passing it through a band pass filter, and then this filter will actually be passing on the signal to an output amplifier. As I said to you, once we receive that particular frequency component, उसका magnitude और भी ज़्यादा कम होगा as compared to the original signal. So we need to amplify that magnitude before we can actually feed it to any metering device that is able to correctly give us the estimate or the an estimate of the magnitude of your that particular frequency component. Fine. So ये जहाँ पे filter होगा, this will be a simple RC filter, and it will be having, let's say, simple RC filter with high quality high Q factor. So it will be actually dependent upon the time constant RC. So these are the states: attenuation, amplification, filter, then again amplification, and then send it to a meter. So this is the structure of any basic wave analyzer. Fine. So इसमें फिर ये जो RC filters होंगे, इनकी कुछ particular property होगी. For example, the capacitor that we use in this is having a very good tolerance. And this capacitor RC filter जो होगा, that should be designed to make sure that you are covering a wide range of frequency components. Fine. Uh, the RC filter will have a high Q factor. Capacitors mostly used here, they are made up of polystyrene. RC filter, it will be having a high Q factor. The capacitors used in this RC filter are made up of polystyrene. Polystyrene actually offer very good tolerance. So your RC filter can be tuned to a wide frequency range. So we can be able to tune it to in from kilohertz range to megahertz range. And apart from that, the bandwidth of this RC filter will be 1% of the selected frequency. That means once we are tuning this to a particular frequency, uh, the bandwidth should be limited to 1% so that there is least so that we'll be able to cover the least possible portion of frequencies. We do not want a number of frequency components to be involved. That will be actually covering up other frequency components as well. Fine. So if we are talking about 100 fs, so only 100 fs should be covered. 101 or 99 fs, those frequency components should not be included within this tolerance, within this bandwidth. Fine. So this is a basic wave analyzer. Of Now we'll be having some special types of wave analyzers. There is uh, audio. These are the types of wave analyzers that we'll be studying. One will be studying the AF wave analyzers, and we'll be studying high frequency wave analyzers. So there's not the basic structure of wave analyzers will be same. Only thing will be the arrangement of RC filters. The tuning of RC filters will vary in these different types of wave analyzers. Fine. The aim is of any wave analyzer aim is same. Selecting a particular frequency component, measuring its magnitude, so while rejecting all other frequency components. We want to measure the magnitude of a particular frequency component only, and we do not want other frequency components at that time to be uh, coming into picture. So one, you have an AF wave analyzer. So this wave analyzer actually works at audio frequency range. So we are actually talking about ten kilohertz to 18 megahertz range of frequency. Fine. So the devices that is actually the RC filter, they will be tuned. They will be actually be the frequency range of RC filters being used in these devices will be anywhere between 10 kilohertz to 18 megahertz. And the important thing about AF wave analyzers is that this audio frequency. This is the block diagram. You have This is the AF wave analyzer. The basic structure will be same. There will be an alternator, input filter, the input amplifier, the filter, the output amplifier, and the meter. Apart from that, there will be an oscillator circuit that will be used to actually first of all ये जो आपके input signal है to make it within this proper range जो आपकी 18 मेगा जो मैंने आपको बताया 10 किलोहर्ट्ज to 18 megahertz. We want our audio frequency, we want our input, our device, our RC filter is actually tuned to only work between these range, that's 10 kilohertz to 18 megahertz. तो अगर आपकी जो ऑडियो फ्रीक्वेंसी है वो इससे बाहर होगी, we will make sure that it is calibrated or it actually is working at the same frequency as that of the RC filter. So we'll actually use an so the input signal is actually first heterodyned to a higher intermediate frequency by an oscillator. So using an oscillator, you can actually make sure that your input signal is having the same frequency as the workable frequency range of the RC filter. So the operating frequency range of this particular instrument is 10 kilohertz to 18 megahertz. So what we do is the input signal uh, is fed to this system and it will be first attenuated and then amplified after after appropriate attenuation and amplification. The input signal will be heterodyned in the oscillator so as to match the frequency range of the RC filter. So the output of this heterodyne system will be the IF range जो मैंने आपको भी बताया and once we are tuned this to this particular workable range, we can feed it to the filter and select a particular frequency component. Uh, After filtration, this will be a band pass filter. ये जो RC यहाँ पे RC filter यहाँ पे designed है, it will have its own amplifier amplification circuitry extra. It will be passed on to an output amplifier and then to a meter device, or we can through a buffer we can feed it to a recorder as well. Fine. So the only difference in case of AF wave analyzers from a normal wave analyzer is that the workable frequency range of your RC filter is 10 kilohertz to 18 megahertz. So as to make sure that your audio frequency is within that limits, an oscillator is used that actually makes sure that your input signal is heterodyned to the workable intermediate frequency range of the RC filter.
सर इसमें एटेन्यूएशन और एम्पलीफायर दोनों कंपोनेंट क्यों लगे हैं? या तो सिग्नल को एम्पलीफाई करना पड़ेगा या तो एटेन्यूएट करना पड़ेगा, दोनों मतलब करने पड़ेंगे एक साथ.
Attenuation, basically, attenuation is a characteristics to remove the noise. Amplification से noise थोड़ी remove होगा.